All right. Okay, guys. So welcome to today's session. On last official session, we managed to display 3 hard-coded characters on our list. So basically, what we are going to do now is start using real information so that we can actually fetch from the API that Marvel is providing for us in order to fetch all the characters list. And of course, in order to make that happen, we're going to introduce some network capabilities that Foundation has to offer for us. So when I say Foundation, of course, we're talking about the package that we can import here, Foundation, that we have talked about before. So basically what we're going to do now is create some symbols that are going to take care of handling that operation for us. So in order to make that happen, we're going to create a new file. This is just a regular Swift file. And we're going to call it, let's say, character service. All right. So let's remove the other information. By default, of course, Xcode is going to provide import Foundation automatically for us. So basically, we can start leveraging all the capabilities from Foundation in order to make the network call. Okay, so we're going to create the actual symbol. In this case, we're going to create a class. But in order to wrap it in like a single module, we can namespace it using an enum. So it doesn't provide the concept of namespaces, but it allows us to create enums or whatever type, and we can nest subtypes within it. The reason why we use enums in this case is because that gives us the advantage of not allowing the user of this type to be able to create an instance of it, which is not our intention. So we're going to create an enum called service. And here we can say we can have a subtype, which is going to be a class called character service. And basically, we're going to wrap all the behavior and the operation per se of the fetch characters operation. So the first thing we're going to do is create, since this is meant to be an input-output operation, it doesn't have to keep state anywhere. We're going to make it static so that we don't have to create an instance for it. And we can create a function for fetch characters. So what parameters are we going to take here? In this case, we don't need anything other than a way to reserve back to our caller. So we have 2 options to do it the async way, async await way, or to do it the completion handler way. So the most basic way to achieve this is the completion handler way. And actually, that was the way that it was used from the very beginning of iOS development while using the concept of blocks. So we're going to go with this, and after on the later session, we're going to basically migrate this to start using async await, which is a more modern way that Swift has to offer for us. So in this case, we will need to provide a completion handler here. Usually what I do is to create type alias, but actually we can wrap within the same namespace. And we can say this is a resolver that is going to resolve a value of type T and an error. And basically, this is going to translate to a function that's going to resolve an optional T. This is the concept of generic pre-match, and an optional error, a return void. So basically, fetch characters are is a function that is going to take a parameter that is going to allow us to resort back to the caller. This means we will need to provide the parameter here. We can label it resolving with, and we can name the parameter resolve. And then we will have to say that this is escaping closure, but it's of type resolver, where the T is actually a possible array of characters with a possible error. And we close the generics. So we are leveraging the capabilities of generics here. I'm sure you have already used it. Generics will allow us to basically generalize the subtypes that the type has to offer. That way we can use the resolver with any type, not just with characters. And in this case, we're just allowing to resolve back with any error as well. Of course, we make it optional because we will be able to resolve either with an actual value because there was a successful operation, or a possible error because maybe there was failure. So in this case, we already have the single parameter that we need in order to make this happen. And now we're going to actually write the operation. So I'm going to go real quick. So basically, we already have an endpoint that we need to target to. So we have your string that I'm actually going to bring it from my notes here. This is the endpoint that we are going to target, the characters of the public API of Marvel. And basically now we're going to compose a request so that we have a successful operation. So we will have to use some values. We need to run some preparations here. We need a timestamp that we need to provide to the API. We need a public key, which you guys, if you want to use the Marvel API, would need to have one of your own, just by creating a free account. So we already have a public key, private key, and we're going to compose it within the request. So also we are going to append it to the URL. So basically what we can do is create an dictionary of parameters that have a key and a value of type any. And we're going to add here the parameters that the request is expecting to be appended on the URL. In this case, we'll have to provide the API key, the timestamp, and a hash. So we're going to here real quick. Public key. We need a timestamp that is going to be labeled just TS. That's the way they are expecting it. In this case, it's going to be the timestamp that we just prepared here. And hash. And hash is basically a composed string of putting together the timestamp, private key, and the public key. Where we will always have a unique hash to provide. But this is not it. We need to provide a way to convert it on an actual hash. So we need to provide some level of encryption. Basically, what I'm going to do is extend the string type. I'm going to add the logic here. Basically, this string will allow us to create an MD5 version of the original string. So we're extending the type string in order to be able to call MD5 on it, and it will return a hashed version of that string. And in this case, it's failing because we need to import the actual framework that provides us with this insecure type. So we're going to import the corresponding framework. In this case, it's CryptoKit. And that's it. It will compile, and then we will be able to call .md5 here. Why? Because this is a string, and we are creating a way to call the MD5 function on the type string. Okay. Now that we have the parameters, we need to actually put them on the URL in order to finish the preparation. In order to make this happen, what we can do is create, separate the components of the original URL first. So we use the type URL components from the corresponding string, which is in this case is your string. And now we are going to say this your component actually have some query items. And we're going to map it from the primary dictionary that we created here. So we are going to say every one of the single key value pairs that we have on that dictionary, we're going to convert them to URL query item. Has a name, which in this case is going to be the key, and has a value, which in this case is going to be the value. And that's it. I need to actually wrap it here so that it parses the value to an actual string. And that's it. All right, so basically we already have a set of your components with the corresponding query items. And what we need to do now is resort back to an actual URL so that we can actually use it on the network request. So we're going to put a guard because in order to generate this back to a URL, we need to make sure that it actually succeeds. So we have some final URL. It's going to come from the URL components, and we're going to say it's going to generate a potential URL from these URL components. Otherwise, it's going to fail. We can say error, valid URL, and we can resolve here our first possible error. In this case, remember the result can actually deliver either a successful value or a failure error. So in this case, since we are actually failing it, we can resolve nil for the value and an actual error. And in this case, we really don't have an error to deliver here because this is kind of a manual error. What we can do is create a type like service error to create our own errors. Like, for example, invalid URL. In that way, we can deliver this service error, but invalid URL. And then return, because we're not doing anything else. And a guard needs to terminate the current operation. Okay, now we are ready to actually start the operation. In order to make that happen, and this is the actual official API to make the network call, we are going to use the concept of URL session. And this URL session will allow us to access a shared instance of a URL session, which is just an instance that we already have prepared to make basic network calls. And over this shared instance, we can call the operation data task. And data task can take an URL. In this case, this is the final URL that we just created here. And then we can subscribe with a closure to the potential result of this operation. We are going to have some potential data, potential response. Well, response, there's always going to be a response, of course, and a potential error. That's something we need to do in order to make this actually run, because we're just saying there's going to be a data task, but we're not actually starting it. We need to resolve this to a task and then call resume so that the actual operation, resume, so that the actual operation actually starts. Okay, now we can provide the operation that we need to run whenever there's an actual response, so that we can tell our program exactly what's going to happen upon a successful or a failure response. So the first thing we're going to evaluate is whether we already have an error or not. So if we have an error, we're going to print it. We're going to say network error and maybe print the localized description of it. Then we're going to resolve a nil value because there was no successful value, and of course the error that we already have prepared here, so we don't have to create a new. And then return, because this is it. We don't need to do anything else because there was an error, so there's no data we need to resolve back to our file. For that, we need to ask whether we actually have some data on the content on the response body. So we can use a guard and say ask whether we have an actual data, and then if not, again another error. But in this case, since we don't have an actual error, we can just resolve with an empty array because there was no data, but there was no error either, and then deliver any error. And then we return. So basically what we're saying here is if there's no error, but we don't have data either, we can basically assume there's no characters to resolve. So basically we say, okay, we have nothing, we have an empty array, but we didn't have an error either. So we just deliver nil as an error. And finally, we are going to, since we already have certainty of having some data here, we can actually transform this to an actual proper structure of data. So the problem is we don't have a way to construct basically the complete structure of the characters because we only have this concept of character with a single name. So I already have prepared the complete concept of the character. So I'm going to bring it here, but we're going to put it in a separate file so that we have a good level of organization within our folders. So I'm going to say we have a character model, an import foundation, and basically I'm going to paste the structure. The response is going to have a data. The data are going to have an array of characters, and the character is going to have a name and thumbnail. The thumbnail can be this. So this is it. This is failing because we are actually replicating the struct character. We need to remove it from here. And let's see. It should stop. Yeah, perfect. So we already have this here, and this continues working because our new character structure still has a name, and it has an optional thumbnail, which by default is nil. So it won't complain here, which is fine. Okay, so with this structure that we now created, what we can do is provide a way to serialize the data that we're getting here. So this data is going to be binary data. We need to convert it to an actual data that we have inside. In this case, we're talking about the character structure that we just created. So in order to make this happen, we need to create a concept of a decoder. So Swift and Foundation provide for us a concept of a JSON decoder. This JSON decoder, we're going to use it. We're going to try this. So we're going to put it in a do block. And we're going to say that we have a character response that is going to be an attempt of using the decoder to decode using the type character response from the data that we just got. And basically this is a try because, okay, hold on, sorry. Because of course this could fail. This could not actually succeed on resolving, serializing the actual piece of data back to a character response structure. So that's why we have to put it in a try and set it. That way we can catch a potential error. If there's an error, we're going to resolve with nil as a value, and of course the error, so that we can do whatever we want to do with it within the UI column. But of course, we can also print the error here. Can say this was a serialization error. And we can say we're going to print the localized description of the original error. All right, so we already have, if we are successful, a character response with a valid structure, and it's going to be of type character response. And character response, as we created it just before, provides a results character array. So being that said, what we can do here is basically call our resolve completion handler and deliver character response dot data and dot results, which is the array of characters. And as an error, we have nil because we didn't have any error so far. And this is it. We have completed then basically what makes happen the actual network call to the Marvel API, so that we can fetch real data and be able to use it within our user experience. But of course, we haven't used this function anywhere, so it doesn't matter how well it works if we don't use it. So what we need to do here is basically go back to the controller and understand what was happening before, because we were actually printing some hard-coded data, some hard-coded characters. But now we're going to say, okay, we initially have an empty array of characters. We don't have anything. So in order to have something, we need to actually make a call to the network operation, to the network endpoint, sorry. And in order to make that happen, we need to contact our character service that we created here. So let's make this happen. So usually those loading operations are started on this lifecycle event called view.load, because at this point the view hasn't loaded yet, but we have everything in place to start running operations that we need to run in order to basically provide the user experience we want to provide. So as part of the setup, what we can do it within the setup, or maybe even create a function, a separate function called load data. And we can say we are going to call this load data function. And we are going to contact our service namespace, character service, and we're going to call our fetch characters, which is going to take our solver function, which is a closure. So if we just double click on it, it's going to automatically create a block for us. In this case, we can get some optional array of characters or some optional error. Okay, so what is going to happen whenever we get this array of characters? So we are going to install them. We're going to say, okay, our original array of characters that we're holding here is going to be replaced with these characters. But of course, we need to verify first that this is not a nil value. So we need to ask that first. In order to ask that, we can use a guard and say characters equals characters else return. And if that's successful, we can install our not nil characters to our original array of characters that we're going to use to display our table view. All right, so we are already making this happen, except there is something very relevant that we are not doing yet. So, which is contacting the original table view, which is called character table view, and letting it know that we need to reload some data. But this is not it. We still need to do something else, but I want to show you guys exactly what's going to happen before. Okay, so let's run this and see what happens. And it seems like nothing's happening. Well, first of all, it does seems like it's showing literally nothing. That's because we haven't even provided a title for the view. So we probably should. We can say the title equals characters list, for example. That way we rerun the application and see a proper title on the navigation bar. Okay, it's here. So actually we can be certain that our screen is actually showing. But what happens with the characters? Is it like something's missing? Okay, first of all, let's see, serialization error. The data couldn't be read because it is missing. Okay. What do we miss here? Okay, let's see real quick. It seems like something is missing from this M first. So we are having a serialization error. It does seem like we don't have data for some reason. So, okay. Let's, the data couldn't be right because it is missing. Okay, that's all. Let me check right quick something. We're going to put a breakpoint around here to see what's happening, because it says it's missing, but we're actually already asking whether it's not missing. So that shouldn't be happening. Okay, so we're setting a breakpoint here. We stop at the breakpoint and we're going to see what's happening. We actually have some 68 bytes on our response, so it seems like we do have something. So for some reason, this is failing because we have no data, but we actually have data. That's all. I will have to debug this quick. It's so funny because I had tried this endpoint just before, it worked just fine. I'm going to restart and see what's happening. I'm using a proxy debugger in order to understand what the network card is delivering back to us. So, oh, sorry. So in order to make this happen, we need to, this is the MarvelDB. We need to some troubleshooting here. Okay. All right, so we already have the network request. You must provide the user key. We have a TS, hash, and API key. What do you mean a user key? You didn't ask for that before. So that's what's happening right now. We have some 68 bytes, but that actually comes from an error, from a network error. So it seems like we are composing something. So okay, let me compare with my notes real quick to see what I missed. We are using the timestamp, the private key. Oh, actually, yeah. So this API key has a lowercase key. That's it. Okay, it should work now. Let's see. Okay, it succeeded. That's it. We already have the results, the characters, the release here, as you can see it. But of course, we are seeing nothing. So what's happening? So that's, well, first of all, we have a breakpoint here. If we complete, we still see nothing. But exactly what's happening? What are we missing? So the problem is, as you can see, this is highlighted. We are interacting with a piece of the UI, which is this table view, within a background thread, because we are running this operation, this fetch, sorry, on a background thread. because this is going to automatically send it to a background thread on this operation called data task. So we need to return back to the main thread, which is the one responsible of handling the UI. So in order to make that happen, we can either here or on the service, we can deliver everything back to the main thread. In order to make that happen, what we can do is use the API called dispatch queue. Dispatch queue will allow us to access the main queue, which is the UI queue, and run an operation on it. So that means we can move this here because we're interacting with the UI on this line, and that's going to happen on the main thread. So if we run again, we are now going to see literally all the characters that the service are delivering back to us. And this is it. We already have real data coming from the API with the corresponding structure, connecting to the corresponding endpoint, and we already have a proper service that is handling all that logic, all that operation, so that on this list controller, we can focus solely on the UI, which is the responsibility of the controllers on UIKit. And this is it. We already have a characters list. On the next section, we are going to see how we're going to improve this experience. We're going to provide some features for the characters and maybe introduce the concept of tests for the UI. These are called snapshot testing, so that we have a proper idea of what the UI is going to look like and start running those tests over and over in order to make sure over time our UI stays consistent. And this is it for today. Please let me know if you have questions.
Data has to come, the data has to be processed on the background thread and then passed to the main thread. That was the error.
Yeah, exactly. Whenever we run this data task operation, it will make all this happen on the background thread. So whenever we run result here, that's gonna be run on the background thread. So in order to go back to the UI, to the main thread, we use this dispatch.main.async. Or what we can do as well, it depends on what our expectations are for our API, we can call dispatch queue right here. And always resolve on the main queue, always. That way, we never have to have that concern on the controller because everything that runs on this block will be run on the main thread automatically. We don't need to provide this here. So that's another option. So, but that depends on whether you're going to expect to be using these fetch characters always on background thread and return immediately back to the main thread. And it's going to depend whether service is going to be used by just the UI or maybe other services that are meant to be running other operations on the background thread. So depending on that, you can either go back immediately to the main thread or not, or just leave it on the background thread and then return it to the main thread only on the UI control, which is here. And this is it. Any other question, guys?
Oh, I think that's it.
Okay, guys, thank you so much. Let's see you on the next session on Thursday.